Okay, so we are talking about like an overview of statics. In statics, everything starts with again, if you compare statics with dynamics, statics meaning that everything is stationary. In dynamic, we say that parts are moving. Now, statics is based on the first law of Newton, but dynamics is basically based on the second law of the Newton. Now, in the first law of Newton, when we say is stationary, meaning that the sum of the force in the x-axis is 0, sum of the force in the y-axis is 0, so that means that there is no motion. Also, there shouldn't be any rotation, meaning that the whole components part machine, they shouldn't move about the axis. In dynamics, on the other hand, we have the motion. So if the sum of the force on the x, this is the second law of Newton. F is equal to ma, but F is equal to ma doesn't have any meaning unless we say that sum of the F on the x is equal to max. They are directional. Sum of the F of the y is equal to may, and on the rotation we have I alpha. I is about moment of inertia and alpha is angular acceleration. Now, going on to statics, 2D resultant force. In 2D resultant force, we have FRX, FRY, sum of F of x, sum of F of y, and then F of r is the root square of FRX and FRY to the power of 2. Because again, resultant force are, if this is FRX and this is FRY, we can actually use Pythagorean to find FR. That's why the equation looks like this. Now the theta is tan inverse of FRY over FRX. Moving on to 2D equilibrium, sum of F of x equal to 0, sum of F of y is equal to 0, then we can find the unknown forces. Moment is about rotation or something like torque. As I talked to you, for something to rotate, it needs to have a distance. That distance has to be perpendicular distance. In this case, if this object wants to rotate about point O, force F1 will not create any rotation because it's crossing through point O, making this distance 0. Now, for force F2, I have a perpendicular distance of D2 that will create the rotation. Moving on, for 2D equilibrium, we already have the sum of the force, but we need to add one more equation for sum of the moment equal to 0. Now, the next topic is about machines. Machines are coming from parts, and for every part, I have to apply these 3 equations. Trusses are like machine. Again, they're coming with different parts. There are different methods to solve them, but again, still we are using the same equation. On the friction, so again, we need to draw something called free body diagram from any part of this. So on the free body diagram, we can say the maximum friction force that can happen is the friction coefficients times the normal force. A normal force is the force that actually between the two bodies that they are in contact with each other. So if you have 2 blocks like this, there is a normal force between these 2 blocks. That force is actually applied from one block to the other block. Talking about normal internal forces are the force in the middle of the object that we can cut it out and we can calculate it. So there are 2, they split from here on in the very last 5 weeks. In ENGT 245, we talk about stress analysis, something like normal stress, shearing stress, or bending, if something wants to bending stress. We talk about torsion, stress from rotation. Now in 232 is more on to 3D equilibrium. So sum of F of x, sum of F of y, sum of F of z, and sum of the moment about the x-axis, y-axis, and z-axis. So thank you for listening to this and watching.